What's up, guys? Welcome to another episode of CCT. Today we're going to do this problem. It looks like a very unique problem, and I kind of read the question already. It took me a bit of time to understand, so I guess I'll explain it. I'm not sure if I yet completely understand it, but yeah. So, let's see. Given a binary matrix between the left. Okay, so we have this binary matrix. So it's like a matrix that only has ones and zeros, and then it claims that given a row sorted binary matrix, which I guess that means that like within a row, all of the zeros are before the ones, right? Like I guess this is a better example. You see in the row, the zeros come before the one, and then it says return the leftmost column index with at least one in it. Again, a very weird problem, but I mean, I guess I see what they're saying. So after you have this matrix that's row sorted, just return the index, right, of the column that has the first one in it. So here, the first row is just zeros, then it was 0, 1, so I guess we return index 1. Yeah, and same case here. The first column had only zeros, and then this one had a 1. So another thing that makes this a little weird, we could only interface the binary matrix, so it's not like a list of list, but we could only interface it through this binary matrix class, I guess. Yeah, okay, and we can't have more than 1,000 calls, so we have to, it's basically saying just be as efficient as possible, which we usually already are as efficient as possible. Mat length, so the matrix length, the matrix I dot length. Okay, this is, yeah, it's saying that the row's length is at most 100, but it doesn't give a limit to the column. Okay. So I guess let's just think brute force for a second. So in order to find the first one, I guess I would just go through the first column, see if there's any ones, and there's no ones, then I'd move to the next column, see if there's any ones. Yeah. But I guess that would be O of n squared time, because in worst case scenario, it's possible that the ones are only in like the last column. And yeah, I doubt that would be efficient enough. Zeros. But okay, so the thing is, it's not sorted based on column. So the only way to tell if this column has a 1 in it. Okay, I kind of had an idea. What if we no, that would still be O of n squared time. I was gonna say, what if we just like compressed it and summed like each of these rows and put it into one row so that we had one list. But that would be O of n squared because, yeah, we would have to sum all of them. Okay, so Okay, what if we did this in a binary search style? So instead of going through everything, we search through the first row, and or rather we can, we could search, and then we search for the last row, and then we have something in the middle. Yeah, so it's kind of binary search. And then we see, like, if the middle has a 1 in it, then we look at the left of the middle. Yeah, so then that would be log of n times the column length, so n. Yeah, that would be an interesting application of binary search. Should I look at the hint or? No, I actually think that's a really promising idea. Yeah. Okay. So let's do that. So remember, this start and end index. Right. Wait. So binary matrix dot dimensions. So the start and the end things are column indices. Yeah, like zeros representing this column, and the length is representing this column. Yeah, let's get the dimensions first. N by, so it's gonna be row column or N by M rows columns. I'm sure it's, yeah. Okay, so this is gonna be, if n's the amount of rows, then we're looking at m minus 1. Okay, so now that we have that, let's get our classic binary search idea, while start is less than or equal to end, and then we get our midpoint by doing start plus end divided by 2. Remember, Python allows overflowing, so this is okay, unlike in C++ where it's not. If you want to know more about that, just leave a comment. Okay, so mid is that. Next is to sum up the mid. So we're going to go for I in range of n and mid sum. It's going to start off as 0. Well, okay, actually we could be more efficient than this, I think. Mid has 1, can be originally set to false, and then we could have I is 0 while binary matrix dot get, so x y coordinate. Does x represent the row? Yeah, I don't know, but I think so. So I'm gonna give it the row and then mid. Okay, so while that equals while get matrix equals 0, or rather, let's just do it like this. let's just do it like this. Mid has 1, gets true, and then, okay. So hopefully we now know if it has a 1 in it or not. So, Okay, so if it doesn't have a 1, we definitely, so if not mid has 1, then definitely the start should get mid minus equals 1. Or minus, no, plus 1. But what I'm now thinking of is if it does have the 1, how do you know the difference of if like this is the first one? You have to look at the one right to the left of it. Yeah, which now makes me think that this should be a little helper function. Yeah. Okay, def has a 1 can take in self, binary matrix, and the column. Okay, so then I equals 0 while true, while binary index get I and column equals 1, then we could just return true here actually, and otherwise return false. And I just saw something else here. Yeah, now I think it makes more sense to make it a range for I in range of size. Yeah, so it goes through. If it ever equals 1, we just return true on the spot, and otherwise false. So now we could call this has a 1, pass in the binary matrix, pass in mid, and pass in n. Yep. Okay, and then this also needs the self thing. So if not mid has 1, so if it doesn't there, then the next question is left has 1. We need to figure that out. Has a 1, pass in the binary matrix, pass in the mid, pass in the n, and then if left has 1, okay, so if, right, I guess, yeah, this is kind of like an else. And let me just make this continue there. Okay, so yeah, so left has that. Then if left does not have a 1, then we could actually return mid. Otherwise, then end must get mid plus 1. Okay. Yep, this is an interesting idea. So, and eventually return negative. Okay, yeah, so there's definitely some other things to consider. So let's just run through the base logic again. So you get the mid, and then you see if the mid has 1. If it doesn't have a 1, then you know that you have to continue searching on the right. Then you see if the left has a 1, and if it doesn't have a 1, then you return the mid. One thing I'm thinking about, what if the left is the mid? If not left, or... I mean, that is possible, right? Yeah, so or end equals mid. I think, yeah, I think that's a possibility. Because I mean, if they equal each other, then it's just the first one. Yeah, if they equal each other, we have to do that. However, if they equal each other and mid doesn't have 1, then, I mean, you might as well keep going to the right, and if it does go out of range, like out of the boundaries, or sorry, if it does fail this, then, I mean, that's fine at that point. Yeah. Okay, I'm a bit suspicious of this, but like we'll get to it in the test cases. Time limit exceeded. Huh. I mean, yeah, that definitely shouldn't be. While start is less than or equal to end. I want to print out mid. Is it getting stuck here? Where? Yeah, there's got to be some kind of infinite loop because this shouldn't time out. Yep. Okay, yeah, so we are stuck at 0, but like, what is end? So end's gonna be 1, start's gonna be 0, so mid's also gonna be 0. And then mid has 1, print mid has 1. That should be true if this is working, otherwise... Oh, maybe it's not. Oh, it is. Okay, it is. So then, that's not true. So then if left has 1, I mean, they already equal. I mean, this is an if else, so how could it be in an infinite loop like this? What? I mean, does this really matter? And mid. This should definitely be... I mean, even if it's not true, it'll go here, and then at least the end will be something else. Okay, so... Oh... Oh... No, not the end equals mid. So if not mid has 1, then you need to go there. If the left but also oh, I see. But it's okay, I get it. Okay, and was already there. Oh, wait. If it does not have a 1, if mid does not have a 1, then that means you need to move the start over. If mid does have a 1, then you need to put it there. Yeah. Okay. It seems like it did get that. So, how do we write these? Oh, I guess it's not too bad. So, let's make it a little trickier, maybe. 0. Let's just put a 0 there first. Let's see if you could get this one. No. Okay. So, it did get that the mid has 1 here. And then but it also said the left has 1. Mid -1. Oh, no, just the start. No, not the start. It is mid -1. But what if mid is the 0th entry? Okay, let's do this. If start equals mid, then we can return mid at this point. Because mid has 1 and right? I mean, that's what we were doing here. If start equals mid, can we return the mid right here? Like if mid has 1 and start, I think we can, but I'm not sure. I'll have to test that. Okay. Yeah, I definitely want to test that. I kind of want to go back to this example when we have it pushed up right to there. And then yeah, because the thing is, if mid doesn't have 1, then it's definitely going to like not get here, I guess you could say. Yeah. And yeah. Okay. minus sound. Okay, let's try this one. This is with 4, an even number. You always want to test even and odd length things when you do this kind of binary search stuff. Yeah, this would did get that. I just want to prove this to myself. Okay, so if the mid has 1, at this point the mid definitely has a 1 in it. And let's say the mid and start do equal each other. The reason I want to do this is so that I prevent this from going out of range, basically. Well, I could just do it as like, if left has 1, I can do a check, and if it does go out of range, then I'll just keep left has 1 as being false. Oh yeah, that I think makes more logical sense. Yeah. Okay. That's just a more sound way to do that. So if mid equals 0, so does not equal 0. Let's do this, and let's set originally left has 1 to being false. And if it doesn't equal 0, then we can call this, yeah. Because then if mid is at 0, well, I guess that's the thing. If mid's at 0, then, yeah, you should, and it does have 1 at this point, then yeah, you could probably return it. Let's just run that code one more time. And yeah, let's try to submit this. See what, wow, it was actually accepted. Nice. I'm curious about their hints. Binary search with a row, yep. Optimal approach. Imagine there is a pointer starting at the top right corner. P can only move left and down. If value of P is 0, move down. If value of P is 1. Value of P is 0, move down. Okay. But there's no ordering. I mean, unless I'm misinterpreting this question, a row sorted binary, like, okay, is this possible, having this first, or does like the amount of ones also have to be sorted? I think this is still a possible case, right? Yeah. Okay. Yeah, so this is a bit confusing me, how if the value of P is 0, you move down. Okay, so you find a 1, and then if the value of P is 1, you move left, so you keep going. Yeah, so if I'll do it up here. So move left, it's 0, you move down, it's 1, move left, move. And then if this row was up here, then it would be like move left, left, left. And yeah, I guess. Try to figure out the correctness in time complexity. Well, the time complexity of that would just be n plus m, which is very fast, and yeah, that's a good pattern recognition. That's quite challenging to figure those pattern recognition stuff out. I'm usually not that good at those. All right, well, at least I got through this binary search variation. I'm a big fan of finding these cool ways to use binary search, and I'm glad I saw through this. idea. They often binary search is the answer for problems that you wouldn't expect it. Like, as long as you could figure out a way to cut the search problem in half, then binary search is a possible thing. And sometimes it's very difficult to even figure out how you would cut this in half. But yeah. Okay. So I'll see you guys next time. Bye.